The lightning talks of today. First, I'd like to welcome Status IM and Status's co-founder Jarrad Hope on stage. Welcome. You kicked off a research initiative to evaluate various token models in the Status network. You have several, and you'll show us how you applied traditional means of financial evaluation to decentralized systems. Welcome, Jarrad.
All right, cool. All right, thank you so much. Well, what a long week this has been. I'm exhausted. Congratulations to everyone here who's still sticking it through. Give yourself a pat on the back. It's been a long week. I hope you've enjoyed it. So I'm from Status. You might know us for our mobile Ethereum clients. It's kind of like a super app. You do messaging, have a dApp browser in it, and obviously a wallet. We try to be entirely peer-to-peer, and we try to run Ethereum on mobile devices with mixed success. Anyway, so we basically have a bunch of white paper promises. They've pretty much all been delivered. They're currently going through security audits, and I'll just run you through how we're starting to look at them these days. So basically, SNT is a compositional token of multiple utilities, which I'll talk about later. There's things like Telenetwork, Tribute to Talk, our dApp store, which is like kind of like a curation market, these kinds of things. And we kind of built them earlier on without really understanding how much value that these things could potentially capture in the SNT economy. We also wanted to find a way that was easy to present to stakeholders of SNT, and we actually found this kind of useful for kind of thinking about our monetary policies around our crypto network. And we've actually modified some of our designs, which we think are actually a better UX and actually capture more value at the same time, which is pretty cool. So basically we approach this by looking at how other investors are trying to evaluate the crypto space and how they're looking to allocate their resources. And it's also important for us as developers on how we think we should allocate our resources and what gets priorities. And some warnings and disclaimer. Basically, this is still early days in terms of evaluating crypto assets. If you're applying these kind of traditional financial models to the crypto space, we don't really have enough empirical data to know if that's actually going to work. So treat this as like pure research and just kind of like a bit of fun. Yeah, that's pretty much it. We also take a pretty narrow view. So at the moment, we're only looking at the net present value of each individual utility, but we're not looking how they interact, and we're not looking at other externalities. So things like improving the user experience and how that could potentially change value capture. The first thing to note is that crypto networks are not companies. So when you're evaluating crypto, it's pretty important to recognize that they aren't. The view that we used to have was that the crypto assets don't actually have cash flows. So using a discounted cash flow doesn't particularly work. However, we have found in our username that a variation of this discounted value flows kind of works pretty well. But what we tend to use from the other utilities is an equation of exchange. And this really lets us understand the flow of money needed to support an economy, and it actually becomes like a cornerstone in how we are looking at these things. And basically, the equation of exchange is kind of like looking at the GDP of a network. So that's the equation there, but how we interpret it is basically M is the size of the asset base. This is actually what we're trying to solve for when we're trying to see how much value it's capturing. V is the velocity of the asset, so how often does the asset change between hands? Price is P is the price of the digital resource being provisioned. It's important to note that this doesn't represent the price of the crypto asset itself, but instead the price of the resource being provisioned by the crypto network. And Q being the quantity of the digital resource being provisioned. So you can pretty much look at the on-chain transactions as kind of a log or a measure of this GDP of the crypto network. However, It's not perfect because a lot of those transactions are moving in and out of exchanges, and you kind of need to get rid of that. So, token velocity, this is something that is kind of like really kind of vague at the moment, in my opinion, and accurately estimating that is a little difficult. But there was some research done at Coinbase in terms of how users interact with Bitcoin, and they came up with a velocity metric of roughly around 20. However, this does fluctuate quite a bit. So for example, in 2016, a lot of people were just hodling Bitcoin. They weren't really transacting with it, which actually meant that only 46% of all the transactions were using Bitcoin as a transactional medium. And then so in 2016, it did have this sort of velocity of roughly 6.5, just to give you an idea of the sort of variation that can be in play. So the other thing that we need to talk about is discount rates or the cost of capital. And this is basically to determine what the future cash flow is worth today. But as we mentioned, crypto assets don't really have cash flows except for in some other instances. So what we're really doing is we're discounting back to a single future utility value to the present. So we're pretty much looking at the cost of capital, looking at a weighted average cost of capital. Really, there isn't a cost of debt, so all we're really looking at is cost of equity in that equation. And particularly finding out what the beta coefficient is. That is basically a measure of the volatility or the systemic risk. And so to do that, we're looking at CAPM, and we use Bitcoin as an index because it has the longest history and it has the most liquidity. And we end up coming up around sort of 15%, and that's what we use in our models. So for every one of our models, we have a set of standard variables. We have assumptions of initial count of current users. We have a count of basically the growth rate of those users, the churn rate of those users, both of those per annum. Because we are developing these systems, we also try to factor in a probability of failure. And I'll talk about that in a minute. And we try to look at a sort of 10-year holding period because there are some compounding things that we can play with. There is also the acquisition costs of users, and we measure that as basically a percentage of the lifetime value of a user. So the probability of failure is important for us because we are developing these things, and basically our burn rate is a risk factor. So we basically need to kind of estimate what we think is the chance of failure and factor that into our models, which helps us estimate these, what we think is going to be the value of these things for us and S&T stakeholders in the future. So basically, very shortly, we have these applicable milestones. If we're way later in the stage, we've deployed this, basically, the value accrual is already kind of exceeding the cost of the capital that was used to deploy it. And so your probability of failure, we estimate it going to be roughly about 10%, and we use that to factor into our models. Then we work back from that. So the key metric for that particular model, if it's growing over time, we go, okay, the risk of failure is probably 15%. If it's positive in general, then it's 25%. If we finally deployed it to mainnet, we take it down to 40%. Active development, it's a 50-50, we'll see what happens. And if it's still being researched, well, 60%. The other thing that's really important for us is we are trying to create these decentralized systems, but it's, it's pretty easy to kind of tank the Ethereum network as it currently exists. So scalability is an issue. So if the particular utility requires scalability, then the probability of failure goes straight up to 90%, and we keep it at that. We also have another one that's kind of relevant to us, which is decentralization, because we don't want to rely on any sort of trusted intermediaries. And so in that case, we have different factors for whether it's highly decentralized, somewhat decentralized, and minimally decentralized. Yep, so basically, I won't get too shilly, but click those links, and you can basically look at some numbers, well, type them out or find the slides, you can't click it. But But yeah, basically we've gone through over these different models, and you can kind of see what we think is going to be the sort of expected value capture over a 10-year period. So this one's in particular for message forwarding within Status, because that isn't free in Status. Neither is inboxing, same thing. Basically, the probability of failure is 72% on both of those. And we're looking at the average price of the message stored or message forwarded, and the quantity available of messages both stored and forwarded. The dApp store actually doesn't use this. We pretty much base the model entirely on the size of the market and expected ratios. Because it is a curation mechanism, and there's actually a better models for that, so it's a little relevant. But you can click on that and have a look at it. The dApp store is basically a curated market, kind of like an app store. Anyone can stake SNT and get their dApp listed. You can stake more to get higher, but also then if you're being a bad actor, you can get slash more. So, yeah. Tribute to talk is basically an economic barrier. So like in instant messages, you're probably, or hopefully you're not used to blocking too many people. But in Status, you don't really block people. What you do is you set a certain price that it's worth them communicating with you. So like, if you really don't like somebody, you set it as like $1,000, and if they've only mildly annoyed you, maybe $5 or something like that. The Teller network is a bit more interesting. This is a fiat to crypto exchange, something like local Ethereum or local Bitcoins. But the difference is it's entirely decentralized. It's insecure. It's being audited now, the contracts. So yeah, stay tuned for that one. It's pretty interesting.
And I think we will be happy to share all the links, but since we have only the lightning talk, okay.
Perfect. Thank you.
Thank you. We might pick up those topics again in one of our token engineering meetups. Thank you for coming, Jarrad, and we will share the links. You get your t-shirts. Thank you so much for being here.